All right, so we have triangle GHI has a scale drawing of it named triangle ABC with scale factor R. So what that means is that we're dilating triangle GHI to get triangle ABC, and angle G corresponds with angle A, angle H corresponds with angle B, and angle I corresponds with angle C. Now, it says to draw 3 possible pictures to represent the situation. So here's 3 different scenarios. We're going to draw a picture for each. Your picture could look a little bit different from mine, and that's okay. So for my first picture, it says that we have a scale factor that's greater than 1. So what that means is that GHI is a smaller triangle because I'm going to be using a scale factor that's greater than 1. So triangle ABC is going to be a larger triangle. So I'm going to make it so the triangles overlap. It does not say what my center of dilation is, but let's make our center of dilation point H. I'm going to make this a right triangle. No rhyme or reason to it, but I have triangle GHI. I'm going to make point H the center of dilation. You could make point G the center of dilation, or I, or even a point off your triangle. It doesn't matter. It's up to you how you want to demonstrate this situation. But with a scale factor of greater than 1, if H is the center of dilation, then that means that it stays where it's at, and H corresponds with point B, and B to A would be a larger segment. B to C would also be a larger segment by the same amount. And this would be a way to demonstrate that we took triangle GHI, we used a scale factor that was greater than 1 to get triangle ABC. Now, if you did a center of dilation off your triangle, so if you had GHI like this, and again, it doesn't have to be a right triangle, but that's just how I drew it. Let's say we had center O, then your larger triangle could look something like this. It would be off of triangle GHI. That would also be acceptable. There's many ways to demonstrate this. I just chose it so that they're overlapping. Now, if I have triangle GHI, and I have a scale factor that equals 1, then that means that your triangle does not grow at all. So that means triangle ABC is actually exactly like triangle GHI. In fact, these 2 triangles would be congruent. And then lastly, what if I had a scale factor that's less than 1? So if I had triangle GHI, let me draw that again. That means that triangle GHI is going to shrink. I'm going to be consistent with my 3 drawings. I'm going to say that my center of dilation was still H, so B would stay the same, but this time with a scale factor less than 1, that means that BA is going to be shorter than HG, and BC is also going to be shorter than HI. Oops. So these are our 3 situations. All right, so now it says, describe each of the following statements as always true, sometimes true, or never true, and justify each answer. So for letter I, it states AB is equal to GH. Well, looking at these 3 situations, we did see that in one of these situations. We saw it here in this middle situation when our scale factor was 1. AB was equal to GH. In this situation, it does not work, and in this situation too, it does not work. So this is sometimes true, but it's only true when R equals 1, basically meaning when there's no dilation that occurred, because if r is equal to 1, that means that there's no dilation that happened. The measure of angle ABC is congruent or equal to the measure of angle GHI. So ABC, GHI, that's always true, because when we're dealing with similar triangles, we know that corresponding angles are always congruent, and angle H is corresponding with angle B. So that's always true. And then AB over GH equals BC over HI. So AB, the side AB, corresponds with GH. So they're saying AB over GH equals the ratio of BC, which that side corresponds with HI. So BC over HI. This is always true because we know that if two triangles are similar, which is exactly what happened here, because when we're doing dilations, we're so showing that the triangles are similar. If two triangles are similar, then all pairs of corresponding sides are proportional. So this is always true. Now, if I took my scale factor times my perimeter of HIJ, and I don't know why they turned it into a quadrilateral at this point. I'm going to change that. In your notes, it has been changed. And then that would equal the perimeter of ABC. So this is something we haven't talked about. However, let's talk about it now. So if I had, let's say, GHI being a 3, 4, 5 triangle, and let's say that I had AB, or a triangle ABC, being a 6, 8, 10 triangle. Corresponding sides here are proportional. Well, if I took the perimeter of triangle GHI, the perimeter of GHI would be 12. If I took the perimeter of ABC, that's 24. So is my scale factor, well, here my scale factor would be 2 because I multiplied all 3 sides of GHI by 2. If I take GHI perimeter and multiply it by my scale factor of 2, do I get my perimeter of triangle ABC? Yes, I do. This is actually a true statement, and it will always work that way. And that's because if we're changing all sides proportionally, and the perimeter is the sum of all sides, then that means that the perimeter is also going to change with the same exact proportion or scale factor. Let's talk about area. If I take the area of triangle GHI times the scale factor, does it equal the area of triangle ABC? Well, I didn't mark that these were all right angles here, but I did mention that I wanted to make these right triangles. So to do the area of a right triangle, you do 1/2 your 2 legs times each other. So the area of triangle GHI here would be 1/2 times 3 times 4. So that would be 6. And your area of triangle ABC is 1/2 times 6 times 8. So that would be, 24. So if I take the area of my first triangle and multiply it by K, do I get the area of my second triangle? I actually don't. A 6 times my scale factor of 2 does not equal 24. However, if we look at the middle triangle here, all sides are congruent. So if I made this a 3, 4, 5 triangle, that means that triangle ABC would also be a 3, 4, 5 triangle. And the areas would be the same. And so if I took the area of triangle GHI and I multiplied it by the scale factor, which is 1, in this situation, we do get the area of ABC. So for this is sometimes true, but it's only when R is 1, because otherwise we actually would take the area of GHI and multiply it by R squared to get the area of triangle ABC. For example, if I took the area of GHI here, which is 6, I multiplied it by R squared. 2 squared is a 4. I get 6 times a 4, which is a 24. I do get the area of my second triangle. So when we do the perimeter times your scale factor equals the perimeter of your image. But here, the area times your scale factor squared equals the area of your image. All right, that brings us to the end of this first level 4 lesson, levels 3, 4 lesson. You're going to move on to the next video.